Welcome to WIN Global Systems, Chapter 10, Part 4. All right, after this online lecture, I hope you have a better understanding of an atmospheric ocean interaction called upwelling. Also, a global phenomenon called El Nino and La Nina, and the Southern Oscillation, and some other ocean temperature fluctuations that we see. All right, so what is upwelling? Well, it's basically where you have rising of cold ocean water to the surface, and this is basically how it's caused. You're going to have the wind blow over the surface here, right? And since water reacts a little bit slower and has more frictional forces than the wind, it starts moving a little slower, and so it's deflected a little bit less in the water by the Coriolis force. So it gets deflected at an angle of 45 degrees. Now again, down below, you can think of these different layers of water being different ribbons of water, and the ribbon above it and the ribbon below it cause a frictional force on it, on the one in between, and it causes it to move a little bit slower and have a little bit less of deflection. And this happens all the way down. As you keep coming down, you see how it's getting smaller and smaller and smaller and smaller, but smaller. It's still being deflected until down here we're on the bottom, and now the deflection is in the exact opposite direction of the wind. Okay? And so this is called, the process is known as the Erkram spiral. And so this colder, deeper ocean water is moving in the opposite direction of the wind. So not only do we get these ocean currents, as you can see two-dimensionally, of the surface water moving, you also get a three-dimensional version in depth of the water. And if the wind blows one direction, down at the bottom, the water's moving actually the opposite direction. And so when this hits a shoreline or land, this cold water's got to go somewhere, and it comes up. And we call these things upwellings. These happen at particular locations on the planet. So in the summertime on the west coast of the United States, specifically California, you have prevailing summer winds going in this direction. So like this. And we're looking at this cross-sectional area right here between A and B, and this picture right here. And you'll see that the ocean currents, deeper water is flowing this way, and it's much colder, and it's brought up to the surface. Now, this is very pronounced in San Francisco, California, where the water in the bay and the surrounding area is much colder than the air, and so you get these effects of its local temperature around San Francisco being a little bit cooler because of this cold water coming up, and the winters being a little bit warmer because you got this 52 to 58 degree water coming up. But in the summertime, you got the cold water there coming up, so it keeps it a little bit cooler. All right, let's talk about El Nino and La Nina. To do that, we have to talk about the normal or non-El Nino conditions. So the surface wind patterns usually converge at the equator here, and you get a high pressure system near South America and a low pressure system over here in Indonesia. And so you get your sinking air coming down this way, and you get the winds blowing this way on the surface, and your rising air here, so you get all the wet and rain in Indonesia, and then you get this cell pattern showing up. But what it's doing, you get all the cold water here dragging this way, and it's displacing all the warm water. You get all this mixing going on. So you get upwell in the deep part of the ocean. You get this upwelling, so you get colder water off of Peru, and you get all this warmer water piling up over here in Indonesia. And usually this colder water is has more nutrients in it, and it's coming up, and so the biological entities in the ocean tend to surround here in the summertime. All right, so that's the normal conditions. You get a high near Peru, and you get a low near Indonesia, and you get these general global circulating weather patterns. All right. So with what happens in an El Nino condition is the high and low weaken and change positions to where Peru is, you get a low pressure system, and where Indonesia is, they get a high pressure system. So the sinking air is down here, and so you get a surface high, and the rising air is here, and so you get a surface low. And then the prevailing wind patterns change direction. So they're blowing the opposite direction before. So that's bringing all the warm water closer to Peru, and all the colder water is, and the thermocline changes too here. So you don't get the ocean welling, the upwelling here anymore. You actually get, since the water's being blown towards the South American coast, the ocean levels can rise here a little bit. And you get what is referred to as an El Nino condition. And usually that brings more rain to South America here and North America at that particular point. All right, so what happens is you get, so I didn't talk about La Nina. A La Nina is an enhanced normal condition. So the normal high pressure and low pressure systems enhance. So this gets much stronger, this gets much stronger, and you get stronger winds this way, so you get more colder water going this way, and less warmer water up around here. And that basically gives us more drier conditions here than we've had before. All right, so back to where we were. All right, so El Nino and La Nina will oscillate back and forth. Okay, and it's constantly going on. Now it's a very slow oscillation, depends on, and really there's no pattern for when you're going to have these conditions. So if you look at these global temperature plots of the surface temperature of the ocean, you can see it being warmer here in Indonesia, and then this warmer water coming closer to Central America, and eventually being much closer to Central North America. And this would be a normal condition changing into an El Nino condition. And this thing will oscillate back and forth one way or another. It could be stronger this way and we'd have a La Nina, and it could be stronger this way and have a strong El Nino. And so this oscillation can also be referred to as a Kelvin wave. But this is a natural happening in the global circulation patterns. And we're not 100% sure why it's happening, but it does happen. It happens on a regular period, regular time scale. It could happen every year, might not, but it does happen. All right, so this is an El Nino condition. See how much all the warmer air, warmer water here, and it's much warmer above normal, and here it's much cooler. All right, so what happens in an El Nino? Well, the jet stream gets a little bit lower than where it would normally be a little higher, and so that brings this warm tropical air mostly over the southern part of the United States, and they have a much cooler and wetter summer. Now, the warmer air stays, the air above the northern part of North America gets a little warmer and drier because it's now not getting all this tropical moisture, and we can have drier conditions, especially where we're at in Indiana. It gets much warmer and much drier than what we normally have for our patterns. And a La Nina condition is, again, the opposite. The colder water is going farther towards Indonesia than it is normally. It's normally just right out here, and it's moved farther east, or sorry, farther west. And what kind of weather patterns does it produce? Well, the northwestern part of North America gets much colder and wetter winters. Where we are at, we get much warmer and wetter winters, like kind of what we had, kind of a warm weather winter. A couple years ago, we had a much warmer winter than we're having now. And the southern part of the United States gets much drier. All right, so there are also some other ocean temperature fluctuations. One happens in the North Atlantic, called the North Atlantic Oscillation. Another one called the Pacific Oscillation. Basically, the ocean surface temperatures reverse every 20 or 30 years. And so these are some global temperature phases of the warm phase of that. And then this is the cold phase. So you can see in the warm phase, you get much warmer waters closer to North America, and in the cold phase, you get much colder waters closer to North America. All right, so I hope you have a better understanding of atmospheric ocean interactions, specifically the phenomenon of upwelling. I hope you have a better understanding of a La Nina and an El Nino and a southern oscillation, and we'll have some lab activities. We'll go through that. And then you have an idea about there's not just La Ninas and El Ninos in global weather pattern fluctuations. There's also some other ocean temperature fluctuations that can occur. Well, that's the end of part 4. And I'll see you next week in in chapter 11.